So wonderful. Good morning, dear LinkedIn community composites experts out there. I have now today the honor to present you the number 4 Composites Launch Engineering Talks. And today with me, I'm now just going clockwise, is Humphrey Carter from Compotech Plus out of the Czech Republic.
Good
Then
morning.
we got Vaden Skyve from AZL in Aachen, Alexander Chaloupka from sensXPERT from Munich, David Lale out of the UK. So we have UK here today. We have Czech Republic here today. Then we got Arne from, I would say also now München, although I guess he's in his own home office. Then we got Johannes Martin from Hamburg, and
Good
we
morning.
have Kai Fischer from Aachen, also from AZL, the owner, the founder of that great company. So our topic today is automotive composites in automotive, and why is automotive so important that we are taking a session only for automotive applications here? Well, first of all, I remember back in the 2000s when composites was really rolled out as the advanced material. One of the first markets that jumped right onto it was automotive, of course. And in automotive, you have so many several fields. And dear community, today you will be presented a very wide range of applications in automotive that you may not even imagined or thought of today. So we always classically think of components in the car, but we have also components for the manufacturing of cars. We have also classic cars today. So just bear with us, stay tuned with us. You will be getting a lot of interesting stuff here. So without further ado, I would like to have Alexander from sensXPERT and Kai Fischer, the two CEOs, first in our round, and I will come back to the other gentlemen later on. So now I need to be careful whom I am removing. So we got now all three gentlemen here from the sensXPERT and AZL. So Alexander is our partner, sponsoring partner of the Composites Launch Engineering Talks for our season fall last year, 2024. We started with automotive, infrastructure, sporting goods, and now we are in automotive. And Kai, he was with IZL. He was hosting or gave us his facilities for hosting our Composites Launch conference. Now it's 2 years ago, and also thank him a lot for the support he's giving us. Now, Kai, I would like to start with you and ask you about the bigger picture. We have in the automotive industry, I know we had this battery panel, for example. Can you give us what is the state of the art on automotive right now in composites?
Yeah, so of course, automotive is still very relevant for the composite industry. So I think Alexander Chaloupka will also give his view there. As AZL, we are doing a lot in automotive, especially currently in battery casings, qualifying different material systems for battery casings, fire testing, but also, for example, for rotor sleeves. So this is one of the highlight components we are currently seeing to wrap rotors or to provide carbon fiber wrappings for making electrical traction motors for e-mobility more efficient. So that can be in the high 7-8 digit lot sizes. And that's what Vaden will also introduce. Yeah, to give additional insights into that, Ilkay, thanks for introducing that 2 years ago. You have been on site here at the AZL Open Day. We had yesterday a nice event here with a lot of experts internationally from the composite industry visiting here the campus at university. So Eric Pierjean, the CEO of the JEC, gave a nice introduction into the trends he observed during the recent JEC show. And then there have been introductions by Zabik, our partner, and also our partner Pressura and Flotex, who founded recently also a company in Turkey for making hydrogen pressure vessels. Yeah, and during this tour, we also had a lot of automotive topics, for example, bonding and debonding on demand for recyclability. We visited facilities here which are dedicated for manufacturing battery cells, so not only the battery casing, which is our topic, but really manufacturing or development of production technologies for battery cells, electrolytes, and so on. And there was also a station where we had to look at how to disassemble battery casings, get the battery cells out, and how to do the battery recycling itself. So a lot of automotive, yes, in the structural parts, but also very special parts, like, for example, composites for the optimization of the traction motors.
We cannot hear you, Ilkay.
I'm sorry. Yes, I did it precautionary. So I'm back. Thanks, Kai, for this introduction and also mentioning your open house, which I remember really gladly and happily that I attended 2 years ago, and it was also my firm intention to come or the intention to come this time. And just shortly before we prepared ourselves, there was this Aero Friedrichshafen show coming up, and I got a nice order from Norbert. So I went to the private jet community yesterday. Was also fantastic to see how many components and parts there are. But aviation, we've talked about it already. Yes, great. So can you talk about the numbers, Kai? The open house. Have you filled your rooms so far? Participant numbers.
Yeah, so it was quite full, and that's also the intention for the open day to also provide networking opportunities. So it was about, I don't have the exact number, I would assume about 60 people in total taking part in that, and then visiting our 8 of our research partners, where the scientists and the researchers and engineers gave insights into their new machines. So it's always the same institutes, but it's always something new to see, because there's a lot going on, of course. And so different groups, I think it was 5 groups, then walking here in best sunshine in Aachen over the campus, exchanging business cards and getting insights into some aspects which are available here.
Yeah,
it was great.
Do you intend to repeat it next year again, or?
Yes, we repeat that every year. So I think it was the 9th or the 10th time we did it. Yeah, so we do it every year, and yeah, everyone is invited. So not only for our close AZL partners like sensXPERT, for example, since a very long time, nearly right from the beginning is a partner from us, but it's also addressing non-AZL partners, because we are also doing a lot of individual cooperation and projects for everyone in the composite value chain who's interested in driving his business forward through joint business and technology development.
So then I immediately jump on to Alexander then. So Alexander, how important are these open days? You are a corporate venture, you are a startup, you are not a sensXPERT, you are not a long established venture. Of course, your mother is Netsch, is I think it's over 100 years old, even longer than that. But for you as a venture company, and then also in the tech industry, how important are these open days when you consider that this takes place at the RWTH in Aachen? For anyone who doesn't know RWTH Aachen, this is, I would say, the center in Europe on composites. Maybe I hope I'm not over exaggerating, but I've come around quite a lot, and RWTH Aachen remains for me the number one spot. So how important is that for you guys?
Now we have two topics. Yes, I can agree. So Aachen is the center for plastics manufacturing. So when it comes to research in plastics manufacturing, Aachen in Europe is the #1 place to be. That is also why we decided in the past, very early as the Netsch Group, to join the AZL partner network. And I wouldn't restrict it to the open days. So yesterday we hadn't have the time to really attend, but it's the entire ecosystem the AZL Aachen has created. So you have a lot of companies there looking for innovation, looking for partnerships to drive innovation. And that is the platform the AZL Aachen is giving us. And even together with the AZL Aachen, all the institutes that are connected from the RWTH in Aachen to the AZL that is more industry focused, this is the right platform to be, because here you not just have an open day, you have the annual meetings, you have specific group meetings where you can focus on specific applications that help you to drive your own business, where you're working on specific topics in an ecosystem of different companies along the value chain very intensively. And you have the probability and the opportunity by AZL Aachen and a high probability to reach the right customers out there in this tech-oriented environment we are working in, to reach the right companies and the right people while advertising new innovations we have created via the AZL Aachen. So this is a very important platform for us in the interaction with the composites branch. And nevertheless, I mean, entire Aachen for plastics environment, we are working together with the Institute for Plastics Processing in Aachen also. So that is definitely for us a #1 place to be, to support research in the plastics and composites manufacturing. You're muted again, Ilkay.
I'm sorry. So the open house is clear. The networkings are clear also, and also thanks for confirming that my impression that AWTH is the center is true. And Alexander, give us your opinion about the stage of the automotive industry in plastics and composites.
Yeah, so the automotive industry, since ever, is a huge driver in innovation due to the fact that they need to take care about high throughput and low costs because it's a mass product at the end. Therefore, even, and there I want to jump on one sentence you mentioned, Ilkay, at the beginning, automotive industry, yes, was one of the first industries jumping on composites, but the very first industry was aviation. So aviation was using composites due to the lightweight potential, especially for the planes, to produce bigger planes, to transport more people at the same time, to lower the consumption of the fuel, all the kind of things. But at the end, composites still have been a very expensive material. Very big potential, very expensive. Therefore, automotive industry jumped in. They recognized the advantages of composites due to their lightweight potential. And I think all of you who are attending here, you know the story behind BMW, the i3 manufacturing. So BMW was a real pioneer in adapting composites for serious cars. And here in this case, a lot of knowledge has been built up. And even there, automotive has shown the innovation potential again, because they took the very expensive composite material and they have brought them to an environment where we can produce composites in the price range that it's really affordable for everyone. And now with the automotive industry looking into e-mobility, hydrogen, here again, we can see that automotive is a huge driver because they are always focusing on reducing costs in driving innovation towards high throughput. And even there, like Kai has mentioned, hydrogen vessels, this is a huge topic. So even we, with our technology of sensXPERT, we are within the hydrogen vessel manufacturing field and topic. But even on the supply chain for automotive, we are even in case a little bit away from composites. We are even in the field of encapsulating electronics for the automotive industry, even for e-mobility. And another topic Kai also has mentioned, the e-motor manufacturing. Even there, in some e-motors, there are no composite structures, but we even have a customer using composites to manufacture components for the e-motor. So even there, automotive, as always, and it still is a huge driver. but we always have to take care about the costs, and automotive is definitely the industry that is working on reducing the manufacturing costs as much as possible to make all the components and the cars at the end available for everyone like you and me.
Yes. Now let me look at the comments. They are flying in now. So Herbert, thanks for being one of our most loyal viewers today. Thanks for being here. Then we have Priyabrat says hello. Hello, Priyabrat. From where are you? Please write it in the comments. And then we got Daniel Krube, and Daniel says the very first were sports in 1980. Yes, I know. Composites actually, Jack celebrated 60 years. So, of course, Composites is a long time available. It's not just started in the 2000s, what I was referring to. I was referring more to the advanced materials phase. Do you remember that when in the year 2000 it started to become very fashionate and very trendy to talk about advanced materials? That was the point I was referring to. Of course, the aerospace is using composites wide before that year 2K. And what I want to do with you guys is, to keep that momentum up and get composites more into the markets. So thank you so much, Kai, for this introduction. Let me get that here out. And Rohan, there's another one. Rohan says hello. And I guess this is, again, Daniel Gruppe, who says tennis rackets. Yes. By the way, if you're looking for people, Daniel is looking for a job right now. Daniel, I hope it's okay that I make a call to action here. So reach out to Daniel if you need some composites experts in your round. So Alexander and Kai, thank you so much. I will leave.
Maybe one addition, if you agree, Ilkay.
Yes.
So,
go ahead.
So manufacturing capability and high volume manufacturing, what Alexander also explained, is important. But reliability is also something which has been proven. And I think reliability, that's also the big contribution of sensXPERT, that with the technology they have and the business model they are providing, to facilitate that everyone is able, on the one hand, to adjust, optimize their process to have best cost efficiency, but on the other hand, also build trust in industries like, for example, e-motors. That's not a typical composite application, that you have technology which assures that the parts are fully cured, that the class transition is reached, and that also contributes to building trust in industries, that composite is a reliable material which is can on the one hand be manufactured in very high lot sizes, but you can also assure the quality and the functionality of these highly critical parts.
Thank you, Kai, for mentioning that, and thank you for the flowers. So great to hear that from you.
Yes, and that's why I love it so much that we have all these leadership functions here, that we have the experts here, that we get such a nice summary and view of the state of the composites in the automotive industry. So thank you so much, both gentlemen. We will do a short break right now, and after this break, we will have Humphrey Carter with us, and Humphrey will tell you about composites in the manufacturing of cars, not in the cars itself, but in the manufacturing, among other things. And then we have lined up so many interesting stuff. So Alexander and Kai Fischer will be later with us. Maybe, Alexander, it looks like that we will be going over one. You have a hard bounce, I know. So goodbye now already to you. But stay tuned, because the comments are coming in. Andreas says, hello together, warm welcome from Marbach. Thank you, Andreas. And we have a LinkedIn user giving us some smileys. So wonderful. Okay, see you in a moment. Humphrey, please take your seat. After this trailer, you will be going.
How do we connect you with the stories within the composites and sustainable materials industry? We are on the ground to find the facts, and we examine big innovative ideas. To this end, we have launched the Composites Lounge Engineering Talks. What is the Composites Lounge Engineering Talks? That is abbreviated by CLET. The CLET is an online format where we are streaming live on LinkedIn, YouTube, and recording the panels for your favorite podcast station. Within the CLET, we are giving you a slot and your seat in a panel where we are talking about the entire value chain within the composites industry, from raw material to the end use. We have raw materials, substrates, and components supplying to OEMs covered in that panel discussion. From our online studios in Germany, we cover events and corporates from France, Italy, UK, Central Europe, and many more European regions. Stay informed, stay connected, stay inspired. Join us for creating sustainable value.
With Composites 360 on tour, Composites Lounge Engineering Talks, and Composites Lounge End User Panels, hosted by Ilkay Özpizoğlu. Weekly on LinkedIn, YouTube, and your preferred podcasts.
Oh, okay. You're muted again.
Humphrey, did you spot anything important in the trailer?
I did notice a few things that I recognize. Yeah, some Compotech pieces there, obviously. Some of that's from our meeting in Czech earlier this year.
Yes, that's right. So this is the Czech after show trailer, you would say, as a preparation for the Composites Lounge Engineering Talks, and we have excuse me, and we have met at Czech World, and we did a fantastic video, and we did a fantastic reel with your bike, which you are using on the Isle of Wight, where you are right now. So you are not in the Czech Republic, you are in the UK on the Isle of Wight. You call the Isle of Wight, interestingly, the Isle of Composites or Carbon, to be more precise.
It's a little bit of a small composite ecosystem. Yeah, we have quite a few producers down here. We have Wind Energy with Vestas. We have Gurit, which started life here as SP Systems, and we also have some GKN. So, and then many smaller manufacturers as well. So, for a small island, we have, I would say, a little composite heart.
And then we have Dr. Carter driving with his carbon bike. Driving with his carbon bike on the Isle of Wight.
The UK side of Compotech is based here as well. Yeah.
Yes. Okay. Wonderful. Let's jump into your first part of your presentation, Humphrey. What I found interesting is that you have some solutions for the automotive factory, not for the automotive car, for the automotive factory. So, community, I will be having now my guests here. They will get from me 2 to 3 or even 4 questions, but I will give them one question, then we will move to the next one. So we will start with Humphrey on the automotive factory. So what is it that you are exactly having there?
So Compotech has been working maybe 20 years now in developing composite structures, specifically in automotive automation, and that is lightweight, stiff structures that can work with the robotics automation actuators for press lines to basically increase the throughput of these automated lines. As you heard from the previous speaker, throughput is something that the automotive sector is very focused on, and by converting some of these jigs and frames into lightweight carbon fiber using specifically we are using graphite or pitch fiber for the stiffness, so we can get high sectional stiffness with low profile sizes to replace an aluminium framework that will be holding lightweight body panel between presses. And obviously the framework is the heaviest part of that system, and what you end up with is a lighter, stiffer framework which can be moved and accelerated faster due to the higher natural frequency. So we're creating we're creating profiles something like this that can mimic the aluminium profiles, and we have many different fibers in here, and obviously some internal structure as well that can manage the deflections and requirements that these kind of sections use. And I think you might have a video which shows some of more advanced composite automation technology that we've developed. This is actually we call it end of arm technology. So it's a part which will be fixed to a 6-axis robot, and this will be picking up body panels or sheet metal and placing it into somewhere along the line of the automation line. And this specific system is what we call a 7, 8, 9 axis. So you've got the 6-axis of the robot, but it also has a linear axis, which is actually made from carbon fiber, and also what we call, I think the video is stalled, but we call it shift and tilt. So the outer arms of this system are moving independently, if you like. There we go. So these are all the different axes of movement that we're able to utilize within this end of arm tooling. And the idea is to be able to have the maximum payload with the minimum amount of deflection. And also the payload of the actual robot is something that you have to consider here as well. So hopefully that, oh yeah, we have another video, just showing the linear axis there, which will be basically passing one panel part from one press to the next press. And that the idea is being able to do that as quick as possible, and also with a lower profile of the framework as possible, which means the press that it's passing the part to only has to open the minimal amount required. And all this is about time saving, basically. Time saving, which in the end is cost saving. Oh,
now this is really interesting, Humphrey. But let me ask you, because I know the automotive industry is also very particular in say the quality systems and everything.
Mm-hmm.
How does a development with the automotive factory run? Is that similar to a component part development, or is this a totally different approach? Because with the component parts, you got this AP/QP cycle where you do the advanced quality production planning, you run through the feasibility study, you do the validation tests and sort of things until it goes SOP, start of production. How does a development with a factory, automotive factory work?
So actually, we are working with a company called Building Automation, which are these guys are designing the press lines being put into the production, the OEM manufacturers. So they are doing the designing of the whole line, and we are doing the composite design of all these components. So we are looking after the engineering and design of that, and developing these composite parts within the framework and specification that they give us. I'm not sure if that really answers your question, but yeah, we're not dealing directly with the large OEMs that give, let's say, they have the overall specification of what they're trying to produce, and then the press line designers will come to us with the more detailed engineering specification. But these are generally, these are generally, some of them are repeated parts, but they're generally designed for that specific press line, these structures.
And because carbon is durable, probably they have an endless life in that factory, right?
A very long lifetime, and obviously, any changes within the design of the body panel usually require slightly different setup for the frame or the jig or tooling. So that is either redesigned, but generally the idea is to have the composite purely to increase the speed. There are some other benefits with the carbon. It does actually do less damage when it's if you accidentally do a mistake and crash the composite into the press or close the press with the composite inside. It tends not to do so much damage to the very extensive press, which is one of the side benefits, I guess, of having this technology.
On a final note, if you need to assess is it a trend in the automotive manufacturing to use composites alongside the robots?
Growing trend, as I say, we started over 20 years ago doing this, and we started using specific fibers, high modulus fibers, in the early 2000s, which really lent itself to these high acceleration, high stiffness parts, and we found a niche application. But generally, yeah, this is a growing trend that many people or car producers are now using within their plants, and it's obviously it's not used in every case, but it's grown along the years. Yeah.
Okay, wonderful. Good. So Humphrey, I will come back to you later. Now let's move on to classic cars. Now, I don't know whether in the past, in the production of classic cars, you guys know that I have a classic car as well. I got a BMW E30, which is now 34 years old, but there's no carbon inside that car, but that would be interesting to talk to David. Humphrey, bye for now. I will see you later.
Thanks.
And David, I have an E30 classic car. And for example, the mirror or maybe the bonnet or the hood, something could be out of carbon. What would you recommend to me?
Oh, there's a whole number of things, isn't there? So the main industry that I used to sort of deal with, it was the Lotus, the K27, and visual carbon is definitely the appeal. When you go into this kind of industry, you either get the people that want the carbon because of the strength and its properties, or because of the visual appearance and the aesthetics. So, and let's face it, when you've got a car which is probably about 800 kilograms, the carbon fiber sort of is a small impact on the whole lightness of the car anyway. So we did a lot of twill, the standard 245. There was a lot of sort of backing it up with heavyweight sort of material to get the strength to it. So we paid a lot of attention to sort of things like matching up the toes there to sort of give like the herringbone finishes, and doing custom work. So sort of like different sort of colors over the carbon. So we all know that there's different things like Hypertext that's out in the market. So, but we found that using a decent prepreg from a prepreg supplier, such as POF, we could get a good visual quality carbon that we could then do the finishing work and with it. So the difficulties is the man hours. So when you're talking about like the bonnet that you can see in that picture, every single one of those leaves having to be individually cut out, it becomes quite a time-consuming product.
Yes. So the numbers on a classic car, of course, are very low, right?
It is sort of you're not looking like the Land Rover Defender, which did what, about 114,000 cars last year. You're talking something here which is probably less than what, 1,000, 2,000 cars annually. So which is a good thing for them, because that's just recently been announced that they aren't going to be having to go into this EV sort of side of things. So they can still continue being sort of the small combustion engines, and this just adds to it.
So let me ask you then, David, these parts. Now, this is, I guess, a shell of the rim, over the rim or something.
That's a replacement wing. So the trouble is, when I started this business, we kind of did it on a shoestring. So we wanted to test the market. So the tooling was manufactured out of fiberglass. So the actual product itself was cooked and cured as an oven cure. So, but where you save the money in not having the autoclave or the heated press system, you then give yourself more work because you've got the post operations for dealing with any kind of pinhole-ins or some of the finishing work. So, sort of with our products, where there was some pinholing issues from the process, we would then have to sort of try and fill those pinholes with some kind of resin-based system, flatten that back, and then do a clear coat system to give it the actual shine and the UV protection that we want to upkeep. So, but the trouble is, when you start getting so manually involved as a second operation, the staffing costs is one of the biggest deciding factors and cost problems sort of in the industry.
Let me dive quickly into the process of once you work for these classic cars. Is it safe to say you have to use thermoset parts? Or does it depend?
I preferred the thermoset parts, but I don't think else. So I think it's just the familiarity to the actual product and how it will perform.
Okay. So what do we see here?
Those are running boards. This is it's not so much a classic car. So this is more the Lotus Elise. So we did some extended seals for a customer. So it had a foam cord to it. That was a standard 245 sort of system yet again. And we paid a lot of attention to weave orientations and sort of the whole layup to it.
Okay. Looks really, really nice. Yeah, this is not classic. This is a new sports car. Okay. This is the Elise, right? The Lotus Elise.
Correct.
Okay. Good. Okay. Looks great. Sounds great. Thanks for providing us with these pictures, David. Then, I will take now Varden into the next round, David, and later I will call you one more time and we talk about PRF and the automotive solution as they are today. Yes.
Awesome. Many thanks. Thank you.
See you right now.
Bye-bye.
So we got Varden. Varden has prepared a presentation for us. Varden, I know also from the open day at RZL, so 2-3 years ago, and we briefly met at Jack World, Varden. Yeah, we shook hands at least, because Jack World is always busy for everyone. So, but it's always good to see people at least walking through the angles and so. Good. Varden, what did you prepare to us?
I prepared everything that we do on winding technology. So I can maybe directly go to the first slide.
Yes.
We have been active in hydrogen pressure vessels for quite some time by now. This is the first hydrogen pressure vessel that we designed. We did it for Aramco. It was a project basically looking for how could we improve production speeds. We worked with our partner Mobility in this, looking at laser assisted tow rack winding, but the complete design, that's also including this green part, the boss parts, was done by us, and also the optimization of all the layers. And also we were happy say when the part was actually made and burst tested, that the actual burst pressure was really conforming very well with our predictions, so that gave us confidence that we could develop this part. So this was really the first one that we did a number of years ago, and then we recognized, and now going to the next slide, that there was a lot of questions from, say, material suppliers, but also equipment suppliers, and also end customers say, yeah, which materials do we have to use? What are the material properties that are needed, say, for pressure vessels? And then we organized a joint partner project with a lot of participants all along the value chain. And we looked at, say, typical, say, nominal 700 bar pressure vessels, so 350 liters or something like that, in both carbon fiber and in glass fiber. Carbon fiber is more for transport, like trucks, buses, and so on. Glass fiber could be very well be used also for more static applications. They would be heavier. And we looked at different material properties. We looked at thermosets and thermoplastic on, say, the typical sets of material properties that are on the market today. We also looked at advanced design options that are not applied in series production yet, but could be applied in future. That's typically called patch design. It's like non-continuous winding, but making, say, local patches first, and then overwind it with other direction of layers. And with that, you can optimize much further. We also looked at different, say, scaling options in dimensions. So it was a quite comprehensive project, say, to learn a lot what materials make sense where. And some of the results you can see here in this graph. What you see in this graph is what people in the hydrogen world call the weight efficiency. You have to compress the hydrogen a lot, but it's a very light gas, and the pressure vessels, they are typically quite thick. So even though it's carbon fiber, it can still be quite heavy. And then the weight efficiency is like how much hydrogen you can carry per vessel weight. And typically today, the best vessels that you can see on the market, they are around, say, this 7%. For instance, this here in the reference, you could see this recent Void tank that's designed for trucks. Had a weight efficiency of 6.5%, and that's already a very good hydrogen tank. And what you can see here is that when you go with this more advanced design options, you can go much better in weight efficiency. That means for the same amount of hydrogen, you use less carbon fiber, which means you have cost reduction. You have also this weight reduction. And yeah, all this knowledge, that we have, say, gathered in this project, say, if people would be interested to learn more about it, they can still contact AZL. We have so-called booster packages where you can, say, in a workshop, you can learn all about, say, the different materials and what they bring, and the different process methods and design options that you have, say, in hydrogen pressure vessels. So this is quite important. We also do a lot of bilateral work in this field also. Yeah.
So this is the part one of your presentation, and we will come back to you. Let me shortly ask you, Varden, regarding this hydrogen pressure vessels. When do we go into serial production? Do you know when are the markets opening really up for mass production? Or is that the crystal ball still?
Yeah. There is a lot of discussion on that. Say, if you look at, say, passenger cars, it's not likely to happen a lot. There's still activities there for very specialized vehicles, but it's more likely that it will be for long distance trucks, where you need to take a lot of energy with you, and then it might become difficult with batteries. And everything where weight is important. Hydrogen is not only used for transportation, it's also used in industry, and it needs to be transported. And you need very special tubing for that to transport hydrogen. We also have designs for that. Of course, it's all about hydrogen permeation. It's difficult to contain the hydrogen. and say, like, if you want to transport hydrogen, you still need a lot of these tanks because you need to transport kilograms, basically, of hydrogen. And that's, say, if you look in the industry, the people that, the companies that produce them, they are all expanding. So it may not happen that much, say, in automotive, in the passenger cars, but in the other applications, it will happen. Also in aerospace, but that takes more time.
All right. Okay. Warden, I will come back to you in a moment. Johannes, please prepare yourself. And with Warden, we will speak on the next round about the rotor sleeves, right?
Yeah, I still have something about thermoplastic pressure vessels. I can show that now if you like, or...
Yeah, let's show it now, yeah.
Okay, then I have to go back to this one. And how can I share?
I have to put this on the screen right now.
Okay, yeah. So in the YEC, you could have seen first, at least designed by us, thermoplastic hydrogen pressure vessel. It's made with Mitsui carbon polypropylene material. It was designed by us, and our partner company, Combility, made it, and it was already burst tested, and the results were quite promising. We are not there yet. It's still the early development, and especially on the processing, you have to do a lot of research to have the maximum quality there. But it looks quite promising. And the thermoplastics, they have a lot of advantages, of course, in recycling, but also like depending on the resin that you use, you can have, say, good adhesion. You can have, say, low void content. It might be very good in pressure cycling, in fatigue resistance. So there is a lot of reasons to look for thermoplastics. We still have to look in how to make it optimum, and that's why we have also will start this new joint partner project that's about thermoplastic pressure vessels, and that's basically making use of these PETS designs, which is typically quite easy when you work with thermoplastic composite materials. You have much more, say, you can make local patches much more easy because you are doing some tape binding, and tape laying and tape binding is the same machine. It's so there's a lot of, say, optimization to be done, and of course then we still have to look for, say, competitive solutions, and that's we will do in the next joint partner project. And if you are interested, of course, you can maybe already scan here the QR code, or just contact us. No.
All right. So thank you, Warden. And then let's continue with Johannes. And we are moving now from automotive factories. We are moving to classic cars now with hydrogen. And of course, hydrogen is bursting loud only for testing purposes. And now loudness is noise. And we want to prevent noise, for example, in cars, right, Johannes?
That's absolutely true. So maybe I start with the Biesterfeld Group. Biesterfeld Group is a solution provider for the automotive industry, and we supply different products as a distributor. We are founded in the 1906, a family-owned company, and we are divided into three business units, talking about plastic materials, plastic granulates for the automotive industry, rubber materials, or specialty chemicals for the automotive industry, and talking about improving the acoustic performance. We have a very innovative product in our product line. It is called Kleibon from company Kleiburg. Kleibon is available in different grades like Kleibon Impact, Kleibon Temp, Kleibon Hybrid, Kleibon Damp, and this last version, Kleibon Damp, is used for sound dampening. It is mainly used for structure-borne sound dampening. I have brought with you one presentation where you see a carbon door, which was conducted in tests together with the company Beyond and Kleiburg. You see here a carbon door with the weight of 5.472 kilograms, the undamped door, and just with adding a little bit of weight, like here you see the damped door has a weight of 5.75 kilograms. You can have some very good sound properties. And yes, you need to increase a little bit the weight, but compared to traditional methods like aluminum butyl or very heavy acoustic foils, which could have a weight up to, I don't know, 4 kilograms per square meter. That is, we are talking here about a fraction of the weight compared to traditional methods. And you see that this was a test where we measured the frequency between 0 hertz and 400 hertz. And if you go to the next slide, Ilkay, you see the amplitude of this damped door, and you clearly see that there is immediately better acoustic improvement over the full range of frequencies, and in particular in the audible range from humans. You see at a frequency of I think it is 60 hertz, that we were able to reduce the sound amplitude from about 25 decibel. And this is not only a very nice advantage of the carbon damp material, it also reduces vibrations. So not only the structure-borne so not only a structure-borne sound dampening effect, but also the vibration of the full part. That means as soon as you have neighboring parts of this carbon part, it leads to less stress of this neighboring part. And also if you have a connection of the composite part with a metal part or with other parts you find in a car, there's less stress in the joint of this material.
Okay, wonderful. But I've seen that I've overjumped 2 other slides.
No, we do not need to show them.
Okay.
This is only, let's say, a summary of the full setup, which materials were used, which setup we had in this experiment. So it's let's say, a standard test report. And I think here the community is more or less just waiting for the results.
Absolutely right. You smashed it. Okay, good. Johannes, so community, if you want to see that sound dampening effect during Jack World,
Maybe I continue. During Jack World, I had the pleasure to have an interview together with Ilkay, and we showcased both doors, and we had a drumstick where we were able to show the community the difference, because talking about a sound dampening effect is worthless if you can't imagine really the sound dampening effect. And you could clearly hear a huge difference between the undamped door and the damped door. And in this video from Ilkay, we recorded both sounds. And if you're interested in the sound of this door and about the performance, please go to this video. I think you can find it in Ilkay's feed on LinkedIn, so that you will get a real life expression of the sound dampening effect.
I will put it in the comments, the link, after we've finished this. So it's really impressive, the demonstration, and I commend you guys for the idea that you have shown this with the stick during Jack World. Okay, Johannes, I will come back to you later on. Now let me continue with Arne Büttner. So Arne is here. Hello, Arne.
Hey.
So we have met so many times now. Also, we have made a video with you at Jack World that is due.
Always a pleasure, Ilkay. Always a pleasure.
Always pleasure. Yeah, we've melted some marzipan, I think, this time. Not chocolate, marzipan. Okay, anyway, Arne, so automotive is, of course, like we also discussed with Alexander before, is an important part. But you are an engineer, and I would like to ask you from an engineering perspective, what challenges are there in the automotive now besides the big picture that we discussed before?
Sure. Thank you again for that question. I mean, I always just can tell it from our perspective, from the sensXPERT perspective, where we have touch points to the automotive industry, and maybe just a few words about what we do at sensXPERT. So at the end, we do sensor-based curing monitoring of plastic processing in general. So we monitor the curing behavior of plastics during the manufacturing, whether it's in contact with the sensor or it's contactless. And we use AI to, let's say, bridge the material behavior, the process parameters, and the part quality to realize or create the correlation between that. And with this, of course, we can optimize cycle times, reduce scrap, and so on. And what does that mean for the challenges in the automotive? Where does the automotive industry use our technology? One point is recycled materials. So by, let's say, the regulations of the European Union, the automotive industry is forced to use more and more recycled materials. And of course, with having these recycled materials, more and more deviations in the material appears during the processing. And this can lead to some quality issues. And by knowing how the material behaves during the manufacturing, whether it's injection molding, compression molding, RTM or autoclave curing, of course, this helps to still have an, let's say, efficient process in regards to cycle times and scrap. So recycling is one. And of course, the other one is general manufacturing of composite parts, where we can assist to lower cycle times and save some money. Hydrogen vessels, for instance, is an application, electrical motors, the overmolding of stators, rotors, but also the rotors themselves. There are some challenges due to the cost, bring that to the automotive industry for the new mobility sector, and there is something we can contribute.
Okay, I mean, we've discussed the sensXPERT parts or the process many times. Please, community, have a look also in our LinkedIn lives. But what would you say is the main benefit now for the automotive industry of your AI curing monitoring?
I mean, first of all, of course, it makes existing processes more efficient in regard as on cycle time and scrap, but also it enables new applications like pressure vessels, electrical motors, because often these applications use very challenging materials, often thermal sets due to some temperature requirements, resistance. And of course, with thermal sets, it's a living material. You have some aging effects, you have some environmental impacts on the material, how they behave during the processes, and then it can lead to some issues during the manufacturing. I have customers that tell me with, for instance, SMC materials, they sometimes have 20% scrap, which is of course a huge problem in regards of costs, but also, let's say, the environmental impact of this production, the CO2 footprint. And by knowing the material behavior, you can get rid of this scrap. And of course, this has a huge impact because there's a lot of cost pressure on the whole automotive industry, especially in Europe and Northern America. On the other hand, of course, you can, as I said, enable new applications like pressure vessels, where you still have a big cost hurdle on the applications on these parts. And by knowing how, for instance, these vessels cure in the oven, we can save a lot of cycle time and with this also money. So because we now on JEC, we presented our new contactless curing monitor system. So we just have to put sensors close to the structure, does not have to be in touch with it. and we still can see the curing behavior of these plastics. And with this, we can reduce cycle times tremendously, sometimes 30%. And of course, this has a huge cost impact on these new applications.
20% on SMC parts is significant. Well, why are SMC parts so insecure? Is there an explanation?
Yeah, I mean, from our perspective, this really comes from the material, because it's a thermoset material, so a reactive material. And as soon as you bring the resin and the hardener together, the curing starts. Of course, it gets prevented by cooling these materials or put them under certain conditions, but still sometimes the curing starts due to changing environmental impacts, to changing storing conditions, and therefore the material can behave different during the processes. And by knowing that in a quantitative number, how exactly the curing and the reaction is emergent during the process, that can help to prevent the scrap.
Okay, thank you so much, Arne. Then we got a clue now of what's going on with the process optimization in automotive. Now, it may also be a bold statement from me, but maybe in year 2000, where AI was not available, maybe that's the reason why manufacturing of composites parts was too expensive. Now with AI entering the scene, it's much more cost effective. And you guys help a lot to reduce this cost and to reduce the scrap, which is, of course, an important feature for sustainability. Okay, Arne, I will come back to you later on in a minute. And I'm going back now full circle, back to Humphrey. And Humphrey, what else is... yes, hi. What else is there that Compotech is doing in the automotive industry? What would you like to highlight here?
Well, of course, beyond the industrial side, we directly produce stuff based around our winding technology, and that can be anything from the drive shafts in motorsports, and also in some supercar applications for linkages and anti-roll bars, being able to wind and optimize tubes and sections to be basically lightweight and high performance is critical in motorsport and high performance cars. But we also have a nice technology that can enable us to connect these structural components with a continuous fiber integration. Basically, we call it integrated loop technology, where we can connect a drive shaft to a flange part, or it can be a linkage. I have a video, maybe I might be able to present it, not sure, showing how the technology works. Maybe I can't.
Wait a minute, I'm trying to locate it. Is it up? It's here. It's here. I saw it. It's here.
Okay, so this is showing the technology, how we're winding continuous fiber around the connecting parts on a strut. This, in fact, is the bicycle you mentioned before, but it can be applied to any kind of connecting component, and we've used it in the automotive sector as well. And behind me, in fact, you can see the finalized frame. How it looks in its final form in this connection. So we have the loop fibers here connecting to, in this case, it's a head tube for a bicycle. But we've done linkages and struts within automotive. But as I say, this is more one-off motorsport applications. And of course, winding fiber lends itself more to straight structures, straight profiles, rather than flat body panels. And that is where our technology is and where the company Compotech is using its know-how and knowledge into the automotive sector.
What is the challenge with 6-axis?
Well, of course, yeah, the technical side is obviously the coding of the robot and combining a design for a laminate into a functional fiber placement with the 6-axis, and being able to code that using. We have a program which we can take a laminate design, or let's say a fiber winding design, and input those based on a parametric components of the tooling. So we will have the design of the tooling, the diameter of the tube, let's say, and the length of the tube, and we can input that directly into the winding software, and that automatically will transfer that to the robot to wind what we've designed as a theoretical laminate.
Okay, so the important part here to note is it's not only the manufacturing engineering, it's also the coding, the software.
Yeah. We have set up our own winding software. We produce all our technology and winding technology ourselves, and we have the let's say the know-how to how to transfer a design into a working laminate. But we also offer that as a turnkey solution to customers who may want to produce many off parts themselves that we can't actually do for them, but we can sell them the technology to do that alongside the software which comes with it. Oh, you're muted again.
Again, the community, I really have to apologize. I have some coughing, and I want to avoid that you have to listen to my cough all the time. So fine. So then we go next and stay on the island on Great Britain, and I'll take David into the picture one more time. David, I would like to talk with you about the automotive situation as it's today, with the tech, the cycle times, the speed of production. How does PRF help in that respect?
It's a fantastic sort of business. Sort of we really sort of take in consideration some of the key issues that I experience within my business. So at the moment, what we struggle with staffing costs, we struggle with energy costs and tooling costs. So POF, we do several different things. We've got the recycled carbon. So the recycled carbon is becoming a lot more involved into the industry. It's easier to laminate. So because you don't have that kind of weave orientation like you do with some of the woven stuff. So once you got it as a preform and you got it into a resin system such as our 570, which is an express cure that you can go into a heated press 140 for about 4 minutes, you are massively reducing labor time, you're massively reducing your energy costs. So, and then to follow on from that, we got the tooling prepreg as well. So one of our sort of key tooling prepregs is the Q tool, which is a 151 laminate system. You put the first ply down, you get that one debolt, and the backing plies can actually then go behind it, and then it's cooled off in that process. So you don't have all the debolt sessions. You are saving yet again more labor time. You save in more processing time, the bagging films. So it's just a win-win situation on all aspects.
Yes, win-win on all aspects. That's right. Yes, that's right. So during Jack World, when I interviewed Vincent Fawcett, we were also talking about the recycled fibers. What is the latest situation there? Do you have already projects with recycled fibers? Is that going strong?
We do. We've got some really quite high volume manufacturing projects that it's gone into. It's a serious consideration. we had a customer that was manufacturing an interior piece, and it was using 4 layers of 245. So this was given a cure thickness of about 1 mil CPT. And this was an exchange for a 400 gram recycled carbon fiber. And this is 100% recycled carbon. So it goes through a filtering process. So you know all the fibers are somewhere between 40 and 60 mil. Anything below that gets filtered out the system. Nothing really beyond that size actually goes through to the process. And it obviously goes through all the other filters to get any kind of contaminants, any metal particles and everything else out of this. And that is then be able to be laid into a mat. It's got some kind of directional properties by the way it's actually laid, and then this can go into any one of our resin systems. So where we got a low temp cure resin system of like a 442, we have toughened systems at 549, and obviously the fast express cure, otherwise known as like a snap cure 570. This allowed the company to have a recycled carbon heated press, had a FR version, which is the FR version is 160 degrees cure at 6 minutes. So this massively reduced their production time. Massively reducing their production time allowed them to then take on bigger projects, further projects, and then we were considered now for further projects moving forward with them. And we can supply that, and we can keep the momentum up. It's just good. Everything is now becoming a little bit more aware of sustainability and circulatory, and this is just our way of doing the right thing. And we are looking forward to seeing a lot more of this sort of material going into further products, and specifically the high volume manufacturing side.
And that's the reason why I took also now Johannes into the picture. Johannes, so David says people are getting more aware of the sustainability part of the business. So how do you see that? Is there a pressure from the customer side? How do you create solutions on sustainability?
Yeah. So some weeks and months ago, we introduced new systems about sustainability in our portfolio. We all know that the composites industry is a wasteful industry. Talking about cuttings, talking about consumables, and there's a lot of waste in those full industry. And we have now introduced a new system from Infinity. Infinity, they are recycling glass cuts, so that we will soon collect all the glass cuts from our customers. And Infinity is then producing with those glass cuts non-woven fabrics, so non-woven fabrics that you can use as a core material for RTM processes, so that there a little bit more of sustainability comes also into this industry. And we are already in touch with some OEMs, and it causes a high interest. But with all, let's say, sustainable projects and with all sustainable initiatives, I think this is not a secret. It takes time. It takes time, but it will come. And from my point of view, this is the right direction, that all of us will do as much as they can to provide the industry with sustainable products. And in the end, I think we all are aware that we are talking here about composites, and the full industry is about sustainability, because we need to improve lightweight construction, because with lightweight construction, you have way better fuel efficiency, or the EV range could be improved if lightweight construction is widely used in automotive industry. You're on mute. You're on mute.
David and Johannes. David, you first. Now, critics say there is not enough recycled fiber available to reprocess it. How do you see that now and in the future, David?
I can see at the moment we have full confidence that the the partner that we work with that supplies recycled material can keep up with the demand. So, and the recyclers, they are using the kit cutting wastes, they're using end-of-life tooling, they're using the end-of-life parts. So the fact that people are now becoming a little bit more understanding with the situation, things aren't going to go into landfill like they have been. So when you think about the marine industry, the amount of waste that goes through that, I've been involved with a company and see sort of like a good ton of waste material goes into one racing sort of catamaran, and the thought of that being just gone into landfill is absolutely, it's almost criminal. So for that to now go and get recycled, it's almost hard to not easy to comprehend why people would not.
Very good point. Yeah, very, very good point. So Johannes, is there a discipline required in this industry? Maybe
maybe not, because maybe not, because in the end, from my perspective, there's no other choice. We talked today about very nice projects from AZL about the pressure tanks, type 4 and type 5 for the truck transportation industry. And there are some more trends currently discussed, for instance, the use of glass fiber reinforced rebars or carbon fiber reinforced rebars for the construction industry. And if those trends will come, and I'm pretty sure that those trends will come, there's not enough virgin material available. Comparing all the projections, what demand is needed, and on the other side, also what the carbon fiber manufacturers announce, how they would like to scale their production, there's a large gap in the future, and we need to fill this with recycled materials.
Yeah. So talking about AZL, Varden, I took you in the picture, and what's your stance on hydrogen when these are going out of service? Do you also consider the end of the life in the hydrogen tanks so that the people who are using the recycled fiber have enough source available?
Yes, we have looked at different methods to recycle both thermoset and thermoplastic hydrogen vessels. And the positive thing about hydrogen vessels is that you are winding with a continuous fiber, a very long fiber. So the way that everybody is looking at it with different, say, processing methods, it's like unwinding. Then you still have the continuous fiber, and then you have the maximum value. Because when you can, of course, you can always cut it into pieces, and then you can make a short fiber compound from it, but then the value is reduced. And carbon fiber is still expensive, so when you get the complete fiber back, that's an advantage. And there is lots of developments. You have the like Senpor, for instance, they have this resin that's easily, say, dissolvable, and that you can reclaim both the resin and the fiber. So and there are more resin variants on this. So everybody is looking, say, like epoxies that you can easily recycle. Say even for the current, say, epoxies that were basically designed for very long life. There are methods, and like in the UK, they have this saturated steam decompression method, which is also very, very effective and very useful to have the say the maximum value returned. There is it's not so easy as it sounds, because in the lab you can easily unwind, but you have to know how did you wind, because your robot has to go to the correct place for unwinding. Now, in principle, that's doable, but that means that also the manufacturers have to have a look at it. But yeah, pressure vessel recycling, I would say, is the more easy one. It's if you look for automotive parts, it can be more challenging, but say the general automotive parts, but even there, yeah. For the technologies, there are lots of developments and institutes and startups that can do it. For automotive, the challenge is more to the organization. Because if you have just, say, a local dismantler and you have a few parts that are composites, it's, say, like collecting it, sending it to, then suddenly that becomes very expensive. So you have to go to more like specialized big dismantling factories. Yeah, it's something that we are looking forward to. It was already mentioned earlier, the new end-of-life regulations still under discussion about percentages and what is recycled material, post-industrial, post-consumer, whether that can be counted, yes or no. But certainly a lot of development will take place there also.
Okay, wonderful. So Warden says there's light in the tunnel, and if hydrogen picks up, hydrogen vessel tanks intendants are easier to recycle than automotive parts. Okay, Warden, shall we then continue with you? You have a second part of your presentation.
No.
We are coming to rotor sleeves.
Yeah. Can I click here? Or, oh yeah, now it appears. Yeah. So what are rotor sleeves? If you the electrical motors for electrical vehicles, they are typically have a rotor and a stator. The rotor is then the rotating axis, and the stator that has a lot of these copper windings internally to make alternating magnetic fields. Now, the rotor, to have, say, maximum efficiency, maximum range, typically, of the vehicle, uses permanent magnets. And then people have found that it's, say, when you go to high rotation speeds, that it's of advantage to contain these magnets by non-magnetic materials, and carbon fiber composite is very suitable for that. And here you see some examples. The left example is from a Chinese vehicle. It's a huge, you see the amount of horsepower, it's not normal. I would say very high power. Tesla S-Plate, of course, is also a premium high power vehicle. But basically it's all about efficiency and maximum power. And then how these rotor sleeves are made, there are basically two variants. You can wind it separately and then push it, say, on the rotor to contain the magnets, the pressed-on sleeve that's called. But you can also directly wind on the magnets. That's of course easier. You have maybe better control on the tension, say, because you need to have some pre-tension there. Disadvantage might be depending on the resonance system. That when you apply too high temperatures, permanent magnets might demagnetize, and then you have to remagnetize, and that's again costing some money. Currently, we are running a joint partner project, again looking at all these different materials, but just on the left to see what we're talking about. Carbon sleeves, they are typically very thin, maybe just 1 or 2 millimeters, or maybe 3 millimeters, and they contain, say, the permanent magnets. When that is running at very high speeds, they want to go outwards, and you have to contain them. The alternative material that's non-magnetic, it's say corrosion-resistant steel, Inconel here in this case. But there is some disadvantages about that. That's of course typically when these motors run at high speeds, they also get quite warm, and then it's of advantage to have carbon fiber because it's a very low CLTE, so it keeps the magnets much more together. And typically you also want to have a very narrow gap between the stator and the rotor, because that's the best for efficiency. And also why carbon fiber? Because then, say, this eddy currents, that's because of the alternating magnetic fields, they are lower, and that means also lower losses. So basically the efficiency gets higher, and maybe it's not like dramatic, but every percentage efficiency counts. So a few percentage efficiency over a wider operating range, it's very much of advantage to get to this lower, to this higher range, higher efficiency. And it's quite small components, so it's always very cost effective to do it. And as mentioned also on the previous slide, if you go to very high speeds, like you want your vehicle to drive not only 130 kilometers per hour, but also 200 kilometers per hour on the German highways, then definitely it makes sense to go to a rotor sleeve. And also, when you have high power output. It's not only applied in car engines. There are other electric motors that also run at high speeds where it matters to contain this magnet. The centrifugal forces that point outwards, and you have to contain them. There are many different applications, and we are studying all the different, say, materials and layouts and different processing methods in a joint partner project that's running right now. Here you see the partners that are participating in this project. It's the majority are material producers that want to learn what material properties do I need for this rotor sleeve, but there are also tier ones. It's difficult to see here on the screen perhaps, but the blue screen one is Schunk. They already produce rotor sleeves today. And also, Toyota is there. They also want to learn for their electric motors. So we see this as an upcoming application, and it's the same binding technique, but on a different scale as we have seen for the pressure vessels. So yeah.
Now I'm curious. Have you been on the German Autobahn, and what was your maximum speed, Warden?
Well,
be honest.
No, say previously, be honest. I think below 200. Say, sometimes I remember you come home late from the airport. Say after 12, the road is empty.
Yes.
Then you want to get home early, but. It doesn't happen that often, especially today. If you drive in daytime, it's not possible.
Yeah,
not where you're living here. No.
No, I'm just kidding, because everyone thinks he can speed in Germany, but in reality, the motorways, they are so suffocated, so full that you cannot speed anymore. There's a natural brake available. Can you explain us in 2 short sentences what is a joint partner project for those who don't know?
Okay. The idea behind joint partner project is basically we gather this idea, say what is of interest to more companies in our workshop meetings that we regularly have at AZL or the annual partner meeting. And in individual talks, and we noticed that there is a lot of interest for a certain topic, and then we also see what is the most often posed question, and the questions are mostly about say how do our materials or how do our machines or processes compare to other options that are there that they want to learn. Is this a business potential for me? So a lot of companies that they want to learn about this topic and want to have, say, honest, say, cost comparison for the different options, so cost, weight, circularity, or whatever, CO2, we also do. And then we just do the work at AZL. We have a lot of CIE simulation to make sure that all the different, say, materials and processes are compared on an apples to apple basis. We also have our own cost modeling software for that. And then the idea is, okay, you learn a lot, but because you are multiple companies basically with the same interest, you pay for that, but basically you share the cost for this study. And typically, the studies don't last longer than a year, typically between half a year and maybe a bit longer, so that you don't have to wait very long for a result. If you join a European funded project that's like a European Horizon or something. You might wait 5 years, and everybody at 5 years later has different interests, and that doesn't work. So that's typically how joint partner projects work at AZL.
Okay, so rather than everyone developing in its own silo, you're offering a platform.
Yeah, and also typically in your own silo you can't do it because you don't have the material data of all these competitors. And of course we will not share confidential data that we have, but at least we have a very good overview on what different materials can do.
All right. Okay. So we are coming slowly to the end, dear speakers and community. And please, everyone, prepare yourself. Alexander, if you are still there, I'm seeing your picture is still there. Kai, if you are there, please prepare yourself. Humphrey, I've just noted you have uploaded another video. Do you want to add something? Now you are muted for somehow, but I cannot see that you are
Yes,
muted.
can you hear me now?
Now, yes, okay. Now I'm not alone. Thanks God. Somebody else forgot it too.
It's easy
okay,
to do.
Humphrey, go on.
But yeah, no, very interesting discussion that Gordon had, and well, perhaps to keep him up, because the picture I was sharing via the portal is of a spindle motor that we use for machine tool, coming back to the rotors. So we use this quite often, and perhaps, Gordon, that's a discussion we can have in after this and with your discussion group. But in the spindle motor sector for milling tools, obviously we find that we can get a lighter weight milling spindle, but also there's a cost element here, because when you're trying to machine the high quality internal surface of that cover tube, it's actually a very expensive process. So being able to wind on a high quality tooling and reproduce that multiple times is actually a cheaper solution for some of these rotor covers. So you get the double benefit there of it being cost effective, as well as you have a lightweight material.
All right. So then we have another edition from Johannes. Johannes is muted. I think I'm
now it happened to me. Okay.
now
yeah,
we
we talked. Yeah. Now we talked about that OEMs have the challenge to reduce the weight of lightweight parts, and we all know that composite parts have often a poor damage tolerance compared to metals or other materials, and carbon impact could be integrated in the composite part, and it results in that the composite part gets more elasticity perpendicular to the fiber plane, resulting in almost ductile behavior. So you see here in the upper pictures F1 nose in a crash test without Crybone. Those videos are available on YouTube, and you see the full nose is completely destroyed with hundreds of splinters. And the video below, you see that it is not destroyed. Of course, it is destroyed, but not in the same way like you see it above. If you see the video, you will immediately see the difference that there is a ductile crash behavior, so that the impact energy is not 100% forwarded to the structure. And we all know, of course, the stone impact on the windshield, and also there carbon impact offers some good properties. Where you go to the next slide, you see some. Can you go to the next slide?
Yeah, I'll try. This is.
Or I can do it. I did it.
Yeah.
And you can imagine that all parts of the car, if it's the hood, the bumper, the underbody plate, or you name it, that was produced of a carbon material, or glass fiber reinforced plastics, they are all subject to damage due to stone impacts, for instance. And here you see that, for instance, the upper layer, the top layer, could be dissipating and distributing the impact layer. And the more Kleinbone you use, the more stress planes you have, so that the impact is completely, or let's say, most of the impact is reduced. And you see here two plates, one plate without Kleinbone, a simple carbon layup, and another carbon layup with Kleinbone inside in a stone impact test, where you see that on the right-hand side, there's almost nothing to see at the surface. So that this is also a very nice innovative material for the automotive industry.
Okay, let me ask Kai. Kai, would you say that solutions like that help to impact resistance? Now, this is maybe a crazy question, but this is what comes to my mind. Makes it also easier to recycle later on. I mean, considering that a totally crashed part, it's full of dust and full of small particles. Excuse me. Or you have a part that is still intact, can be recycled easier. What do you think?
I think both has its dedicated options. As Baden said, it's important that the logistics and the business models for that are also implemented. So from a technological point of view, things are very mature today. But it's a logistical topic, and people or the business models should also be capable for that it's competitive and people can make money out of also the logistics. Mm-hmm. Yeah. And it's also a very nice example. So it's a very impressive combination to combine the elastomer together with the composite, and this is also a very good example for the composite industry, that you always have these development cycles. So technologies which have been there in the past. So I very well remember when we at IKD applied this technology for sideboards in aerospace to optimize the acoustics. There's also a nice PhD thesis by Dr. Tobias Preuss from that time, where he integrated these elastomeric interlayers into honeycomb structures, so that new drivers are coming from the industry, and then all these technologies find new ways for application.
Okay, good. Alexander, so what do you think about the spread, the wide field of applications that we've presented today?
It's great to see that there are so many applications upcoming, and even for us to see new challenges in these applications where we can all together work on creating nice solutions that are sustainable on the one hand, where we can generate safety and at the end trust in all the different applications and products, even when new products are upcoming, because that's always a topic. You need to convince a lot of people very fast to really pave the way to bring it into the market.
So, and this is, I agree with you, this is the fascinating part, the facets of composites is so diverse, and there are so many different application fields. Now the rotor sleeves, now the automotive production, the classic cars, and what you have. There are so many wide fields, and if you are from the automotive industry listening, watching this today, and you have a part now on your desk that your boss wants you to design from a metal or aluminum sheet or whatever, why not consider a composite instead of aluminum and steel? Go the extra mile. You see, we have a lot of experts here, and this is only a small choice of people that I've seen and watched and talked during Czech World. And there are many, many more in the Composites Lounge, more experts that can help you with all sorts of applications. There's nothing that composites cannot really solve, in my view. Yeah. Okay, so my final round is now the classical call to action. What is a call to action? This is a social media term, and that means what should people do next once they have listened and watched to you guys. And I go again clockwise. Varden, you are the number one. What is your call to action to our viewers?
I would say if you are looking, say what can you do, and when you want to have a very quick estimate whether there is some business in composites or there is some application that can bring say cost reduction by using composites, just have a first quick call with us, because we can always first discuss before we go in and do some further projects. I think that's it's always about, can we make money, yes or no, and basically to get that insight and say a quick estimate you can always get. No.
Very good point. Humphrey, your call to action.
Yeah, well, you can see the wide-ranging applications and different technologies that we have within the composites industry. It's not just a one hit, one fix. And with Compotech, we are focused on one specific, let's say, technology with winding and fiber placement. And but we love to come up with solutions to any problems that people come to us. And if you've got an idea and you want to make it from composite, we'd love to talk to you. And we can offer our approach. I think we have a slightly different approach to, let's say, most composites, because we're not looking at from a let's say standard fabric point of view. We're looking at it from a whole process point of view. And but I think it's very interesting, and the discussion today has been very interesting as well.
Yes, very fruitful. Very fruitful. Yeah. We have really great experts today. Johannes, what's your call to action?
Yeah, I can only engage the community to get in touch with Biesterfeld. Biesterfeld, our slogan is competence and solutions, and those solutions are provided with experts. So we have in our sales team, we have a lot of mechanical engineers, we have chemical engineers, we have aerospace engineers. And if we are contacted at a very early stage of the project, we can recommend sometimes new and innovative materials, like you have seen the Carbon material that combines a good world of rubber elastomer and the composite part, bringing the composite part to a completely new level of performance.
And just as a small addition, Biesterfeld is a group of companies, and you have some regional affiliates, like in Norway.
Yeah. So we are a family-owned distribution company. We have in more than 50 countries an own entity serving more than 120 countries worldwide. And in all of those 50 countries, we have product experts with a high expertise from the market.
All right. Kai, what's your call to action?
Yeah, my call to action. I would say get connected in formats like here in the Composites Lounge in a digital way. But I would also encourage get out of the office, get on the road, and also meet people in live, talk about technologies, use your networks, get inspired on your ideas, inspire people of the composite solutions, which may not always have the very simple answer, but when you talk about, you will find the perfect match and good answer. And I think for the composite community, it's also about promoting composites as a sustainable material. So other materials lobbies are pushing hard their interests, and also in context of sustainability, we always have to remember the end users on the solutions regarding sustainability, recycling, on the potential for cost saving and so on. So it's about talking on the potential for composites and doing promotion for this technology constantly. so that it's always perceived as the option to go.
Absolutely. You've touched two very important points. One is the Composites Lounge, the online format. We can be only a resource here. You're absolutely right. Yeah. Inspire the people, start the dialogues, but the dialogues must be then deepened, of course. And the second one is, of course, the passion for composites and get composites more into the mind of the people. Yeah. Okay, David, what's your call to action then?
My call to action would be for people to review their systems, review material choices. And so is the speed everything's moving at the moment. What you did sort of 5 years ago, or even probably 2 years ago, has changed and developed, and there's so much more options out there. So I would like people to not always stick with we've always done it this way kind of attitude, and actually start thinking a little bit further ahead, because otherwise margins are just going to get squashed, and it makes it difficult for everyone. So we're down on the south coast in the UK, so I travel all over the UK to see people, and all what it will cost you is a cup of coffee. So I would like to sort of have a chat with people and see where we can help.
Absolutely. Nice spot where you are, by the way.
Thank you.
All right. Alexander, your call to action.
Yeah, my call to action is don't hesitate to reach out to anyone who you think can help with your new ideas, with your challenges. Even if someone of us here in this group is not the right one, we know somebody we can connect you with.
Absolutely smashing. You nailed it. Yes, we know everyone who can help you within our network. Yes. Arne, what's your call to action?
Well, Alex already said or asked to reach out to us if you have issues with your processes, so please do so. And in regard to time, I would propose to have lunch or coffee.
Okay, wonderful. Good. So, dear community, we have talked about automotive applications for composites, and it was really an inspiring. We had really deep dives in certain applications, like the hydrogen tank vessels, or the new upcoming rotor sleeves, 6-axis multi-winding production. We had Johannes with the Crybone, Arnes and Alexander's process optimization, bringing AI into the picture. David's classic cars as a starter, and of course then the fast production for automotive applications. And Kai gave us a nice overview about the scenery that is going on in the composites industry. Saying that, I thank you so much, dear panel, for being part of our show. This is the fourth format of the Composites Lounge Engineering Talks. We have covered already aviation. We have covered infrastructure and construction, sporting, and this was now automotive. We will carry on with certain others like the eVTOL, the marine industry. So if you have anything important to say in that industries, please reach out to me and we find a slot for you guys to discuss this on an engineering level. You've seen this is a purely and technical engineering type of show and format, because this is, with all these marketing and sales that is running around on all LinkedIn, I want to make a difference by diving more deep into the engineering part. And I also enjoy it a lot. So talking with the experts on the engineering. Yes, so this has been streamed now on our Composites Lounge page. And it will be available on YouTube and also soon as an audio podcast. Thank you for everyone who was attending today. I've always looked at my smartphone. There were some attendances, but of course we know that you will watch this later. So for everyone who's watching this later, if you have questions, write them in the comments or just write to the people that are here in the panel straight on LinkedIn. They are all on LinkedIn and they're checking their inboxes. I know that from experiences, so don't worry. Said that, I wish you a very nice weekend. Easter holidays are coming up. If you are going on Easter holidays, have now great holidays, and I will speak to you guys soon. So this is an outro, and for the panelists, please wait this 1 minute, and then we will make a short debriefing.
Okay.
I hope I get now the English one.
Haben Sie sich schon immer gefragt, wie Sie die harte Arbeit Ihres Composites-Teams sichtbar machen können? Über Sichtbarkeit und relevante Reichweiten werden die Lösungen nicht nur bekannter im Markt, sondern auch viel mehr wertgeschätzt. Kommen Sie und werden Sie Teil unserer Composites Lounge Community, um Leichtbau- und Spezialtechnologien für EndnutzerInnen zugänglich zu machen und Projekte, Kundschaft und Talente anzuziehen. Die Composites Lounge Community steht UnternehmerInnen, Führungskräften, Fachleuten und ManagerInnen offen, die mit ihren innovativen Verbundwerkstoffen eine bessere Welt schaffen und entscheidend zum Erfolg ihres Unternehmens beitragen möchten. Wenn Sie also ein Hidden Champion im Mittelstand sind und nicht wissen, wie Sie Ihre Lösungen am effektivsten promoten können, schließen Sie sich einer unterstützenden und innovativen Community an, die darauf abzielt, die Erfolge im Bereich Verbundwerkstoffe für EndnutzerInnen sichtbar zu machen. Die Composites Lounge Community feiert und fördert die besten Innovationen, Leichtbautechnologien und nachhaltigen Lösungen in den Bereichen Automobil, Luftfahrt, erneuerbare Energien, Öl- und Gasindustrie und vielen mehr. Machen Sie mit unter www.compositeslounge.com.